The M777, lightweight in appearance but powerful in capabilities, stands in an open field. This 155mm towed howitzer with a .39 caliber barrel is crafted from titanium and aluminum, making it lighter than most similar howitzers, weighing just over 4 tons. This weight allows it to be quickly deployed by road and air, on a military truck trailer or on a helicopter sling, meaning the weapon gets to where it's needed before the enemy can change its plans. The M777's main advantage is its accurate long-range fire. A standard high-explosive round can be fired reliably at a range of about 20 kilometers. A rocket-assisted round can fly up to 30 kilometers, and the Excalibur family's precision-guided round, with its satellite navigation, travels even further and lands very close to the target, saving shots and time. The rate of fire of such a system is also important. The crew can fire a short burst to engage the target and then switch to a more leisurely pace to avoid overheating the barrel and losing accuracy. A howitzer round is a 3-part assembly: a projectile, a modular propellant charge, and a fuse. There are dozens of types of projectiles. There's a standard high-explosive shell, a rocket-propelled projectile, a smoke shell for creating screens, an illuminating shell that opens in the sky and creates a bright dome for night operations, and a high-precision shell with pre-programmed coordinates. Fuses also vary. Some have an instantaneous detonation for soft targets. Some have a delay to detonate after passing through an obstacle. And some have a radar detonation above the target to blanket the area with shrapnel. During exercises, the crew uses an electronic fuse setter, which sets the desired mode in seconds, and the operator double-checks the setting on the data plate to rule out errors. Training always begins with the crew taking up position. The tractor unhooks the gun carriage, the soldiers lower the trails, retract the bipods, level the platform, and check the level and direction. The gunner zeroes the sight, adjusts the azimuth to the target, and compares the readings with those from the firing post. Simultaneously, the calculated mission is transmitted over the radio network. It contains everything needed: target coordinates, altitude, ammunition type, charge, elevation angle, and lateral aiming, as well as the firing method and who is making the adjustment. Above this work lies another invisible layer. These are the observers on the front line and the calculation team. The observer reports what he sees, makes adjustments, and sometimes requests illumination or smoke. The calculation team in the firing platoon calculates the firing position for each gun. They take into account wind at altitude, air and propellant temperature, bore wear, barometric pressure, and even the current humidity level. This data is fed into the A2 onboard computer, which prompts the calculation team for the final angles and dwell times. The better the input data, the fewer shots will be needed. At the gun position, each role has its own section. The gun commander maintains communications and issues commands. The gunner directs the gun's traverse, and the assistant gunner is responsible for elevation. Number 1 takes the shell, removes the protective cap, feeds it to the breech, and, if necessary, rams it with a hydraulic or manual rammer. Number 2 sets the fuse and delivers the modular charges in the quantity specified in the mission. The charges are color-coded and numbered to prevent confusion. Number 3 monitors the breech closing and signals the readiness signal. The gunner, on command, pulls the trigger cord and remains in position until the command, "Recoil complete," is given. Then comes the recoil and roll forward. Sights are checked, a new setting is made, and the next cycle begins. The shells are heavy. A typical high-explosive shell weighs over 40 kilograms, so training includes proper ergonomics. Soldiers lift the ammunition from the crate with 2 people or use slings. The ammunition is stored on pallets, with a small forklift nearby delivering new shipments and empty crates being returned. All this seems mundane, but it's precisely here that the rate of fire and crew safety are determined. Field training isn't limited to individual work. The battery learns the fire and replace technique, as modern counter-battery reconnaissance quickly pinpoints a position based on its trajectory. After a short burst, the crew dismounts the gun in a matter of minutes. The trails are raised, the trailer is secured, the camouflage net is stowed in the truck bed, and the tractor moves the system to a backup position. Reverse maneuvers are practiced in the same way. Quick return to the previous position using predetermined markers and landmarks to resume firing from the previously measured points. At night, the work changes, but not the principle. Lighting is minimal at positions, only red lights and closed lamps. IR markers are placed on the rear sights, so friendly forces can see the vehicles through night vision devices. A clock with a timer is kept on the commander's desk, as night fire missions require greater precision. Illumination rounds are often used. They deploy over the target and hang from a long pod, casting a high, even light. Sometimes smoke is used to obscure friendly maneuvers. Safety is an integral part of every step. During training, they thoroughly practice delayed firing, partial recoil, and broken cartridge cases. The crew has a clear plan of action. If a misfire occurs, the gun remains aimed in a safe sector. The dwell time is recorded, and the breach is not opened until the report and command are given. Gloves, earplugs, and goggles are not a formality, but a way to protect your hands, hearing, and vision in the midst of a ton of metal moving at high speed. A few words about maintenance. A barrel's lifespan isn't measured in kilometers, but in equivalent full charges, and the crew records every shot to ensure prompt replacement of inserts. Before training, they clean the bore, lubricate the guides, check the recoil brake, tighten the optics mounts, check the recoil pressure. With this discipline, the howitzer maintains its rated accuracy and won't surprise you at the worst possible moment. The M777's lightweight is a plus for mobility, but a towed system is more vulnerable than a self-propelled one. So training includes camouflage, simulated false positions, and radio silence. Sites are prepared in advance. Shallow nests for the plowshares are dug, and hidden access routes are marked. When the crew arrives at night, they don't search at random, but position themselves where everything has been prepared and checked during the day. Another important detail about ammunition. On a large table, the fusers set remote settings. For illuminators, this is the altitude and opening time. For radio-controlled fuses, it's the operating sensitivity. Inert heads are used for training purposes to develop the mechanics without risk. Sometimes they practice with smart shells, but even here, there's a ritual. The target coordinates are double-checked, then the coordinate system is verified, and then the referencing is confirmed with the observer. This tedious triple check saves an expensive shot and reduces the chance of error to zero. Logistics are no less important than the equipment. A battery requires numerous trucks, pallets, forklifts, a maintenance tent, a water and fuel tank, spare tires, a site repair kit, and generators to power the electronics. In the field, it looks like a small town. It has a duty kitchen, a corner for radios, a storage area with camouflage netting and shovels, and a rest area. When everything is organized properly, a fire platoon can remain in position for weeks and remain combat ready. A good artillery school has another important aspect: weather monitoring. Every few hours, the field meter reports wind and temperature. This data is used to calculate and adjust fire. If it's raining, they change the lubricant, dry the charge cells, and monitor moisture in the ammunition racks. If it's hot, they monitor barrel heating and take longer pauses. These are simple things, but they're what keep hits within the target perimeter. At the end of each day, the crew performs a quiet ritual. The gun cools under its cover, the barrel is sealed, the gunner zeroes the sights, the commander records the shots and checks, and no one leaves until the instruments are returned to their proper places. The ground is left with level areas, compacted tracks of tractors, and stakes driven into the ground. Tomorrow, these marks will once again help them get up and running quickly and accurately. This is what the M777's life in the field looks like. Not flashy credits, but a chain of small, well-executed actions. A lightweight design provides speed. A variety of ammunition options provides flexibility. Training gives confidence, and discipline and logistics transform the howitzer into a tool that does its job without unnecessary noise or movement. And that's the whole point of the M777 in the field. Not a flashy image, but a precise rhythm of work where every role is in its place and every second counts. When the command comes, the battery rises silently, like a single organism, and within a minute the target is already in the correction table, and within 2, a crater on the ground. After firing, the gun recedes into the shadows, leaving only a hot trail in the grass and a mark in the logbook. And that's how they maintain an advantage without unnecessary noise. Tomorrow will be a new frontier, new weather, new instructions, but the order of operations will remain the same. Therefore, the result will be repeated. Speed gives life to the crew. Precision conserves ammunition. Discipline saves time. Together, this turns the light titanium howitzer into a tool that does its job where it matters most.